proper use of statistics in research for COVID-19 vaccines effectiveness. In statistics, we have one formula that can be used in this subject. And the formula is following. Vaccinated people in a given country divided with alive is equal to vaccinated dead divided with dead. Okay. So if, let's say, we would vaccinate in January 30% of population, taking in account that vaccine has no impact on that rate, we should have in the next months 30% people which died, they should be vaccinated. Okay. What we calculate for England, we did not have the vaccination status for the entire population. So we did calculation vaccinated alive in England, infected, vaccinated dead, and infected dead people. Yeah, out of that persons, sorry, out of that we can calculate proportional number of infected, vaccinated, dead. We can calculate proportional number, and once we have this proportional number, this number should be always bigger than the number that we get by statistics. In this case, vaccines are saving lives. If the statistically obtained number is bigger, that means that vaccines are taking lives. Now, some people ask after our article was published, what about Simpson effect? There is no Simpson effect in this impact of Simpson effect in this calculation because the age distribution of infected, vaccinated, dead, and infected dead is very similar. Okay. Now we have to understand what, in this case, Simpson effect means. Let's say that we would have two groups of people. One group would be from 50 to 70, okay, and the other group 70 and above, okay. Now we would vaccinate only people which are 70 plus, and the other group we would not vaccinate, and we would got results that mortality rate of this group 70 plus is bigger than the other group. If we would have if we would got this result would not have any statistical significance because here is a case of Simpson effect, because older people are dying with a higher rate than younger people. This is how the Simpson effect can influence results when we calculate effectiveness of vaccination. Now, to get a really precise result would be the best that we would divide entire population in 5 age groups: 0 to 20, 21 to 40, 41 to 60, 61 to 80, and 80 plus. Okay, and we would calculate using this formula we would calculate for each group separately. In this case, we would get a very precise result of how much life were saved in a given group because of vaccination, COVID vaccination, or how many lives were lost, how many people died prematurely because they have been vaccinated. This is statistics then that every mathematician or every scientist that know statistics know that it's proper, and this is the most accurate way if we want to really uh, calculate the effectiveness of COVID vaccination. We cannot properly calculate effectiveness of COVID vaccination only doing some calculation inside the group of the people that were vaccinated. Okay, the effectiveness of COVID vaccination can be calculated on the basis of non-vaccinated group. This group will really show how many lives vaccination has saved or how many lives vaccination has taken. So thank you very much for your attention. Our article was published a few days ago, and now I got questions about Simpson effect, and I answer now, and I hope now that everybody is happy. Thank you very much.